But an alien technological object might maneuver, it might have an intent that we cannot initially figure out.
The shock hits immediately as SPHEREx returns data that stops the control room cold. 3i Atlas is wrapped in a CO2 megasphere so massive it stretches 420,000 kilometers across, a bubble larger than Earth's entire diameter, surrounding an object smaller than a town. No one speaks at first. The numbers look impossible, almost like a mistake, until a second scan confirms it. The scientists know what they're seeing shouldn't exist. Not in the solar system, not in any solar system. In real time, analysts watch the CO2 output spike to 10 times stronger than its water emission. A chemical ratio that shreds every comet model ever studied. A normal comet coughs out gas in wild, chaotic jets. But this CO2 spreads in a perfect uniform shell, as if something is shaping it, controlling it. The emission pattern even forms layered sheets, thin and smooth, nothing like the violent outbursts expected from a dying interstellar rock. Then comes the most unsettling detail. The CO2 refuses to fade. It stays stable, chemically intact, far longer than physics should allow, and worse, it pulses. Every brightness spike in the CO2 shell syncs with tiny, unexplained fluctuations in 3i's reflected light. It's rhythmic, slow, intentional, as if the object isn't venting gas, but breathing. A quiet panic spreads through the monitoring teams. Some whisper the unthinkable. This does not resemble cometary behavior at all. It resembles engineered thermal exhaust, or a process so foreign that planetary science has no name for it. How can a 2.5-kilometer body generate an atmosphere nearly 500,000 kilometers wide? How does something this small command something that large? The deeper SPHEREx looks, the stranger it becomes. The megasphere behaves not like debris, not like gas, not like dust, but like a system. Organized, persistent, coherent. And a single terrifying question rises in every private briefing. What kind of object produces a planet-sized atmosphere while staying almost completely intact? And just as scientists begin to process this anomaly, SPHEREx detects something even more disturbing in the next data set. The tension begins instantly. SPHEREx instruments scanning 3i Atlas in routine mode suddenly spike with unexpected energy at 2.7–2.8 microns. What should have been quiet, dying water vapor turns into sharp bursts, clean pulses, each one spaced apart with unnerving precision. Analysts freeze. These aren't chaotic outgassing events. They look timed, structured, almost programmed. Within minutes, the fear spreads through mission channels. A comet this old should be bone dry. Instead, 3i is releasing water like a machine pushing out signals. The emission rate is far too high, contradicting everything known about thermally processed interstellar bodies. Nothing this dehydrated should be producing anything like this, and definitely not in repeating bursts. Then the images sharpen. And the shock deepens. The water coma doesn't bloom outward in a natural spherical cloud. It stretches, it widens, it aims. A long plume forms on one axis, sharply directional, as if 3i is pointing something. The shape refuses to change for days, staying locked in the same orientation even as the object moves. This can only mean one thing. The source of the water is fixed in place, not rotating, not shifting, not behaving like any natural vent on any known comet. Researchers bring up the light curve next, hoping for an explanation, rotation, wobble, anything. But the variation stays under 15%. An object rotating slowly cannot create pulses this sharp. It cannot maintain a directional plume for this long. It cannot blink water into space like a beacon. Whispers begin behind closed doors. Is that vent repeating on purpose? Is this a thermal beacon? Nobody wants to say it out loud, but everyone is thinking it. Mars once showed methane spikes, brief, localized bursts that scientists still can't explain. 3I's water pulses look frighteningly similar, except stronger, cleaner, and far more regular. And then comes the detail no one can ignore. When plotted against its inbound trajectory, the plume aligns almost perfectly toward the sun, not randomly, not partially, directly, as if the emissions are being aimed along its path or towards something it is approaching. But the most disturbing part? The emissions have zero thermal correlation. 3I gets hotter, but the water output does not follow the heat curve. It follows something else, a pattern, a trigger, a coordination no natural body should possess. Scientists stare at the data, unable to dismiss the possibility that something inside 3Y is reacting, responding to solar approach. Not melting, not venting, but responding. And as the pulses grow steadier, faster, and more synchronized, a terrifying question rises across the mission channel. If these emissions behave like signals, what happens when the object gets even closer to the sun? The moment the stacked SPHEREx images sharpen, scientists feel the air leave the room. Before them is a sight no comet expert ever expected to witness, a nucleus barely 2.5 kilometers across, wrapped in a coma so bright it drowns its own parent body by a factor of 100. It looks wrong, not chaotic, not messy, but intentional. The brightness surges as though the coma itself were the main object, and the nucleus only an afterthought. But that is only the first shock. The coma isn't made of dust or soft, evaporating ice. It is filled with massive icy fragments, chunks so large they should have broken off millions of years ago. Objects this big should be scattering outward, drifting apart, peeling away into space like every dying comet in the solar system's history. Instead, they stay close. Too close. The image analysis turns eerie. The coma refuses to resolve. Every attempt to sharpen or isolate individual fragments produces the same impossible result. The pieces remain clustered, packed tightly together as though held in formation. Veteran researchers think back to Hartley 2, the hyperactive comet famous for jets so violent they blasted boulders into orbit. But 3I Atlas is the opposite. No jets, no chaotic spray, no tumbling fragments. It behaves like a silent, perfectly stable version of Hartley 2, a paradox that no one can explain. Then comes the detail that halts conversation entirely. There is no rotation signature. None. The fragments do not drift randomly, do not twist, do not spiral the way outgassing debris should. Instead, each piece follows the next in eerily synchronized motion, maintaining fixed distances, locked into what looks disturbingly like shared control. The models break. Every simulation fails. Outgassing cannot do this. Cometary physics cannot do this. And yet, 3I Atlas is doing it. Worse, the coma isn't just bright, it pulses. Every flare of brightness matches the strange H2O rhythm detected earlier. The water emissions and the coma fragments flicker together, two separate systems moving as though they share a single heartbeat. In private chats, researchers whisper a phrase they refuse to say on record. It looks like a swarm with rules. If the coma is not drifting apart, if the fragments are not escaping, if the system is pulsing in coordinated rhythms, then 3I Atlas is not shedding material at all. It may be repositioning it. And that terrifying possibility leads directly into what scientists uncover next. The tension spikes the moment SPHEREx releases its newest orbital model. 3I Atlas is moving retrograde, slicing against the natural flow of every planet, moon, asteroid, and comet in the solar system. Scientists expected strange behavior, but not this. In observatories worldwide, analysts freeze mid-sentence as the updated trajectory loads on their screens. A retrograde entrance from interstellar space is already rare, but a retrograde path this clean is almost unheard of. Then the second shock hits, one far more unsettling. When researchers apply light curve corrections to strip out brightness noise, the orbit reveals a series of micro-adjustments, tiny course shifts that no natural object should be able to make on its own. Each shift is subtle, tucked within a plus 15% flux variation band, too small to blame on rotation, too defined to dismiss as mathematical noise. Something is nudging 3I Atlas. Something consistent, something deliberate. As the object drifts closer to perihelion, the deviations intensify. They appear at moments of rising thermal pressure, almost as if 3Y is anticipating the sun's heat and preparing for it. Veteran astronomers compare overlay after overlay, but the conclusion only grows more disturbing. 3Y is not behaving like any comet from this solar system, nor from any planetary system we've ever studied. Even its velocity is wrong. Instead of accelerating predictably toward the sun, the curve flattens, as though the object is applying invisible brakes. Some quietly call it retrograde with intent, a phrase whispered behind closed doors at space agencies and never spoken in public statements. No one wants to admit what it implies. When scientists compare 3I Atlas to Oumuamua and Borisov, the terror deepens. It mirrors Oumuamua's unexplained acceleration, yet keeps Borisov's icy stability. A hybrid of contradictions sitting in a category that should not exist. Its path looks less like a comet tumbling through gravity and more like a controlled glide, with course corrections that mimic anticipation rather than accident. Now, as attention turns to the weeks ahead, the question becomes unbearable. Are these adjustments random quirks of physics, or is 3I correcting its own trajectory? And just as analysts begin to debate the implications, a new data spike appears, signaling the next anomaly is already unfolding. The alarm spreads through the analysis rooms the moment the new SPHEREx data arrives. 3I Atlas is blasting out massive amounts of CO2, yet showing almost no CO at all. For comet scientists, this is the equivalent of a heartbeat without blood. It should be impossible. Every known comet, from the Kuiper belt to the far-flung Oort cloud, releases CO and CO2 together. That pairing is so fundamental that entire formation models depend on it. But 3I breaks the rule with surgical precision. The imbalance is so extreme, so mathematically clean, that researchers immediately rule out random interior variation. This isn't a natural quirk, it's a pattern. Then the deeper cut comes. A tentative signature of 13CO2, a rare isotopic form that should barely exist in bodies that formed around normal stars. But here it is, floating off a 2.5-kilometer object hurtling toward the sun. The ratios don't match any known comet family. They don't match our solar system. They don't match other observed star systems. They match nothing. Even more disturbing, these chemical outputs stay stable for 15 straight days. No spikes, no chaos, no thermal randomness. It behaves like a regulated release, steady, calibrated, almost measured. Something is controlling the proportion of gases escaping. Something is maintaining the balance, but that should be impossible. Selective heating? Internal differentiation? Not in a frozen relic this small, not in an object supposedly drifting through space for millions of years. And the biggest red flag of all, CO should be the easiest gas to release. It evaporates faster, escapes sooner, and leaks from even tiny fractures. Yet 3I keeps it locked inside as if it's being filtered out on purpose. This is no longer the chemistry of geology. It's the chemistry of design. Astrobiologists start whispering behind closed doors. They speak of structures, not stones, a hollow interior, a layered core, a chambered system built around specific chemical priorities. None of them want to say it publicly, but all of them feel it. The spectral fingerprints don't look natural. They look processed, even engineered, long before 3I ever entered our solar system. And if CO is missing because it was intentionally removed, the question now spirals into the one no one wants to answer. Removed by whom or by what? And the next anomaly hits even harder, pushing scientists toward a possibility they hoped they'd never confront. The tension begins instantly. Analysts watching SPHEREx data see something that makes the room fall silent. 3I Atlas, a tiny interstellar body expected to fade as it nears the sun, is doing the opposite. Instead of weakening like Hartley 2, a hyperactive comet in its final collapse, 3Y is ramping up. Its emissions rise with clean precision, not chaotic sputtering. It behaves nothing like a dying object, and everything like something preparing for a new phase. Thermal models say 3I should be burning out. Years of radiation damage should have left it inert, barely able to shed a trickle of gas. Yet, SPHEREx shows a disturbing transformation. Each pulse becomes sharper, more coordinated, almost rehearsed, as if the comet isn't reacting to heat, but responding. Water-ice absorption features match ancient Kuiper belt fragments, but the chemical ratios are wrong. So wrong they can't be traced to any region of our solar system. It's like comparing fingerprints. The shape matches, but every detail inside is alien. Even more unsettling, 3I grows organized as it warms. The coma tightens. Brightness pulses lock into rhythm. The chaotic wobble in its trajectory begins to smooth out as though a stabilizing force has taken over. Gas output curves that should be wild and deteriorating instead become coherent, unified, almost synchronized with the sun's increasing intensity, like a device powering up under a growing energy source. Its coma doesn't fall apart. It locks into place. Its motion doesn't drift. It steadies. Its emissions don't scatter. They merge into a pattern. Nothing in the data resembles a final breath. Everything resembles activation. Inside mission control, scientists stop speaking in technical terms. They whisper. They choose their words carefully. Because if 3I isn't dying, if it isn't weakening, if it isn't collapsing into dust like every other exhausted comet, then something far more disturbing remains. They whisper the possibility no one wants to put on paper. 3I isn't shutting down, it's switching on. And what it is switching into remains unknown.